Hello guys, and welcome to the GCE panel online. In this paper we are looking at June 2024 Pure Maths Mechanics paper 1. June 2024 Pure Maths Mechanics paper 1. Please make sure you subscribe to this channel as we progress with the video. Let's take the first question. So question 1 reads, the functions f and g are defined as follows. F of x equals x squared minus 1 and g of x equals 2x plus 1. G of x equals 2x plus 1. Find g of f of 2. So we start by looking for f of 2. And f of 2 will be equal to 2 squared minus 1, which is equal to 3. Now g of f of 2 will just be g of 3, and g of 3 will be equal to 2 into 3 plus 1, and that gives us 7. So a key for question 1 is B. A key for question 1 is B. Question 2. If log y base x equals 2 and xy equals 125, then the values of x and y are respectively. So from this first equation here, we can see that y is equal to 2 to the power x. X to the power 2. So substituting xy equals 25 will give us x times x squared equals 125. So from here is that x cubed equals 125, and this implies that x is equal to 5. And if x equals 5, we know that y is equal to x squared, right? We know y equals x squared from this relationship, so y will be equal to 25. So x is 5 and y is 25. Question 3. The vertical asymptote of the curve y equals 1 over x minus 2 into x plus 3r. So to get the vertical asymptote, okay, we equate the denominator to 0. So x minus 2 equals 0, and equally have x plus 3 equals 0. So we have the values at x equals 2 and x equals negative 3. So these are the equations of the vertical asymptotes. X equals 2 and x equals negative 3. Question 4. When the polynomial p of x equals ax cubed plus 5x squared plus 2x minus 8 is divided by x minus 1, the remainder is negative 3. What is the value of a? First of all, we start by looking for, we know that x minus 1 equals 0, implying that x equals 1. And since it leaves a remainder of negative 3, what does that imply? It implies that p of 1 is equal to negative 3. So this will give us, when we substitute 1 here, we are going to have a plus 5 plus 2 minus 8. That should be equal to negative 3. So we have a minus 1 equals negative 3, implying that a equals negative 2. So we have a equals negative 2. Question 5. The set of values of x for which that expression is less than 0 is. So looking at this expression, since the numerator is always positive, we know that x plus 1 squared is always positive, right? So x plus 1 squared is always positive, plus 3 will always be positive. So we can just focus on the denominator. Since you know that the numerator is always positive, so our issue here should be the denominator. Okay, so for this to be less than 0, we can just use a number line since we are not actually showing our working. So the boundary solutions for this denominator are negative 3 and 2. the boundaries are not included, right? Since the boundaries are not included, it means that B cannot be the answer because boundary is included as well as C. So because you make the function undefined. So we are working with A and D. So let's test. We can take 0 here, and when we fit here, we're going to have 3 times negative 2. And what does this give us? Negative 6, which is less than 0. So the region is lying between negative 3 and 2. Okay, so this is the correct region. D, the correct region. You can equally use tables. If you want to use tables, there's no problem. Okay. The next question is question 6. A function f on the set of real numbers is defined as follows. If f of x has a limit at x equals 1, what's the value of beta? So if there is a limit at x equals 1, then it means that the upper limit equals the limit to the left equals limit to the right. Okay, so this implies that 4 beta plus, when x equals 1, we'll have 4. That's limit to the left should be equals limit to the right. Here, 4 times 1 is 4. Minus beta squared minus 4. 4 minus 4 is 0. So we are left with 4 beta, or then bring it this way, beta squared plus 4 beta plus 4 equals 0. So from here we see that beta is equal to, what's the value of beta? What will be the value of beta? Okay, the value of beta will just be negative 2. Question 7. So that brings us to question 7. Question 7 reads, we have the statements P and Q as follows. So actually there's a table here, even though we cannot see the table. So this is a truth table, okay? So for this truth table, what do you observe? You observe that when P is true and Q is true, it's true. This is true and this is true, is true. When the first is false and second is true, is true. So the points where it is not true is here, the last one. Can you see this? True, 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 false. So what statement is this? It's an AND. It's an OR statement, sorry. It's an OR statement. So for question 7, the key is C. Please guys, I know most of you watch this channel, you watch our videos, and most of you don't even subscribe. You don't share our videos, you don't even leave a comment, not even a like. Please, if you can do all of these things, it's really going to help us to know the type of content we should make more for you. If you're watching this video and you have not subscribed, please subscribe. You're in a digital era, you cannot tell me you don't know how to subscribe. If you don't know, try and do it, okay? And also share this video, leave your likes and comments. It's going to help us to know the type of content, because the videos that we see that students like are the ones that we're going to work more on. Please like our videos, please subscribe to our channel. Thank you, because you know you're going to do it, and God bless you, mashallah, as you prepare for your exam. Question 8 reads, given the lines L1, L2, L3 and L4, which are all vectors, which pair of lines are parallel? For you to find the pair of lines that are parallel, just compare their direction vectors. These are all direction vectors. If any of the direction vectors are the same, or one is a scalar multiple of the other, then the lines are parallel. So this the first one, compare the first one and the second one, you see that these two have a relationship. Okay, so this second one is 2 times the first one. This one has no relationship with any of them. So the lines that are parallel here are just L1 and L2, because the direction vector of L2 is 2 times that of L1. So that's the reason. Question 9. A relation is defined on a non-empty set S called a partial order if R is. So what's a partial order relation? For a relation to be of partial order, first it must be reflexive. Okay, and it must also be transitive. So it's reflexive, so it cannot be this last one. and then it should be transitive. Second one is transitive, also transitive. And the third property, which is actually the second property, is it is anti-symmetric. So only B fulfills all of these three conditions. For partial order, it's reflexive, anti-symmetric, and transitive. Okay? Question 10. If the sum shown is equal to 10, then what's the value of M? So the first thing we realize here is that we have the summation is from 1 to infinity. So this is actually the sum to infinity. The sum to infinity of this series is 10. So how do we get the sum to infinity? So beginning at r equals 1, when r equals 1 and we substitute here to get the first term, we're going to have m. So the first term is m. So t1, which is equal to a, is m. Now to get the second term, when r equals 2, t2 will be equal to, substitute 2 here, you're going to have m on 2. So from here, our common ratio is equal to a half, and our first term a is equal to m. Okay, so how do we get our sum to infinity? Our sum to infinity will be equal to a, that is m, over 1 minus r minus a half, and that value, they say it is 10. So from here, what does this imply? When we solve, we see that m is equal to 5. Okay, so m equals 5. Question 11. So the first order differential equation that we can obtain from this is from the function y equals ax plus ln x is. So when we differentiate this, we are going to have y prime, or let me use dy dx. Dy dx equals a plus, when you differentiate ln x, you have 1 over x, right? So we can multiply all through by x. You're going to have x dy dx is equal to ax plus 1. But from this equation that has been given, we can see that ax can be given by ax is equal to y minus ln x. So we are going to replace this ax here by y minus ln x, okay? So we have x dy on the x equals ax y minus ln x plus 1. So which of this equation does it match now? Okay, D, it matches D. Matches D. That's question 11. Question number 12. Guys, please make sure you subscribe to this channel and you share this video. Share to all the WhatsApp groups and Facebook groups in which you are. Question 12 reads, the shaded region represents. So for this question, the shaded region is a region outside A. So A prime intersection what? Intersection B, right? So it's just A prime outside A intersection B. Question 13. The function f of f is on the set of real numbers is defined by f of x equals that. What's the domain of this function? So this function will be undefined if this denominator is equal to 0. So we have to exclude those values that will make the denominator to be equal to 0 from the domain. So our domain will be the set of real numbers excluding those values. And when we solve this quadratic, we will find out that the values that make this thing to be undefined are negative 3 and 5. Right? So our domain will be equal to that set. So key here is B. Question 14. A curve is defined parametrically by x equals 2t and y equals 2 on t. What is the Cartesian equation of this curve? So from this point, from the first equation, this one, we can see that we can make t the subject. T will be equal to x on 2. We now substitute in this one. We'll have y to be equal to 2 divided by x on 2. So that's going to give us what? 4 on x. So from here, multiply both sides by x, we'll have xy is equal to 4. xy equal to 4. So our key is A. Question 15. If R equals the vector I plus 2j plus 2k and s equals the vector 2i plus 3j minus k, then what is R cross s? What's R cross s? So since it's R first, we have I, j, k, and then for R you have 1, 2, 2, s you have negative 2, 3, 1. So if you cross this, what are we going to have? Alright, when you do this cross, our result is going to be negative 4i minus 5j minus 5j plus 7k. Any of the methods you use. Negative 4j minus 5, negative 4i minus 5j plus 7k. Okay, so we have C. The next question is question 16. So question 16, given that f of theta equals sine theta minus root 3 cos theta, expressing f of theta in the form r sine theta minus alpha, where r is greater than 0 and alpha is an acute angle, you obtain f of theta to be equal to. So from here, r sine theta minus alpha, when you expand this, we are going to have r sine theta sine alpha minus r sine theta sine alpha. So equating components here, we are going to see that this is sine theta here and this is sine theta. It's that r sine alpha equals 1. And for this other one, you have cos. Okay, sorry, sine theta cos alpha, r sine cos theta sine alpha. Okay, so from here, you're going to see that this is cos theta and this is cos theta. So we are going to see equally here that r sine alpha. Okay, this is r cos alpha. R sine alpha equals root 3. So from here, our r is 1 squared plus root 3 squared square root. That's going to be equal to 4. So r equals the square root of 4, which is 2. So you can see that either A is going to be the answer or C. And our alpha is going to be tan inverse of root 3. And that's pi on 3, right? Because it's 60. Pi on 3 is 60. So our key is C. So our key here is C. Question 17. You have f of x equals x squared plus kx minus 3 has a root in the interval 1, 2. Then what is the range of k? So if there's a root in the interval 1, 2, then we can use the intermediate value property, right? So we can say that when x equals 1, so 1 squared plus k, well, 1 squared is 1, right? So 1 squared is 1. 1 plus k minus 3 times, now when x equals 2, you got 2 squared is 4 plus k plus 2k actually plus 2k minus 3. This product should be less than 0. So from here, I have k minus 2 into 2k plus 1 should be less than 0. So when we test these different regions, we are going to see what happens. What are the boundary solutions? What are the boundary solutions? Boundary solutions are 2 and negative a half. And they're not included, right? So we test and see which one is going to give us. If you put 0 here, this is going to be this region. So the region is the region from negative a half to 2. Negative a half to 2. Or you can use a table to do the same thing. That takes us to the next question, question 18. Given that the sum and product of roots of the equation 2x squared minus 2x plus q equals 0 are equal, the value of q is... So first of all, writing this one in the form x squared minus sum of roots plus products, we'll have x squared minus x plus q on 2 equals 0. So if the roots are alpha, let me say a and b, then we'll have a plus b, the sum of roots is 1, because this is minus the sum of roots, right? And we are equally being told that okay, the product of roots, the sum and the product of roots, AB. Product of roots is AB are equal. So if the sum of roots is 1, then the product of roots is also 1. So from here we have A plus AB plus, as AB equals 1 and A plus B equals 1. So here we can make 1 the subject of the formula. So you have A into A minus 1, because B should be equal to A minus 1. Oh, sorry, B should be equal to 1 minus A. So we have that will finally give us the equation negative A squared plus A minus 1 equals 0. So if you solve this out, you are going to get same solution. Well, but actually this one is going to be a longer method and it's going to stress us. The better thing to do here to avoid all of this confusion is this. We can go directly here by saying that since we are being told that the sum and product of roots are equal, now the sum of roots is negative 1, the product of roots is q on 2. So this implies that q on 2 is equal to 1, and this implies that q is equal to 2. This is the best thing to do. I'm sorry about that. Okay, say sum and product of roots, because the sum of roots is 1 here, the product of roots is q on 2. If these are equal, then q should be equal to q on 2 should be equal to 1, right? Okay, question 19. The sum of the first n terms of an AP is n into 2n plus 3. The nth term of the progression is, so the first term T1 is the same as the sum of the first one term. So when n is equal to 1, what do we have here? We have 5. The second term T2 is given by S2 minus S1. Right? So when s is equal to 2, we have 2 times 2, 4 plus 3, 7 times 2, 14. 14 minus 5, which is equal to 9. Okay? So from here, our first term is 5. Our A equals 5, and our common difference is equal to 9 minus 5, 4. Therefore, the nth term Tn, which is given by A plus n minus 1z, will be 5 plus n minus 1 times d, 4. When we simplify that, we'll have 4n. We'll have 4n plus 1. 4n plus 1. Question 20. I've taken a bit of this space, so let's clear this out. So question 20. So question 20, given that the absolute the modulus, okay, find the modulus of whatever has been given there. So if you just look at this keenly, you will see that the numerator can be written as 5 into the modulus of negative 1 plus 2i, right? All this on 1 plus 2i. So but the modulus of this and the modulus of this are the same. Forget about the signs, okay? So the result here is 5. If you like, you can expand and do it any other way you want to. There is no issue. So note that the modulus of negative 1 plus 2i is the same as the modulus of 1 plus 2i, because you are squaring these things, right? Yep, so they'll cancel out and that's what you will have. Question 21. The line L has equation that, and the plane pi has equation that. What is the sign of the angle of the acute angle between the line and the plane? So the sign of the acute angle sine theta is given by absolute value of A cross B, all this on mark A, mark B, right? Or it's better to, since they are vectors, let's write it this way. Since they are vectors, we'll write it as the direction vector cross the normal to the plane, all this on the absolute value of, or the modulus of the direction vector times the modulus of the normal. Okay, so if you do your calculations, this is what you obtain. You start mark A. Now know that this is the direction vector for this line, and for the plane, the normal to the plane is 2i. So the normal to the plane n is equal to 2i. You can get it from here. 2x 2 is 2i plus 2y 2j minus z, so minus k. So that's the normal to the plane. Okay, and from here we have seen that for the d mark d is equal to, that's 1 squared plus 3 squared plus 4 plus 2 squared. 3 squared is 9 plus 1 10, root 14. So mark D is root 14. And then for the normal to the plane, the magnitude of the normal is 3. And for A cross B, the modulus A cross B or D cross N, the modulus is at 3 root 10, because it's root 90, right? And from here, actually the answer to this one is not here, because the answer I obtained is root 10 on root 14. So check that out. If you have any comments, please leave in the comment section. So the key is actually not here. So, but since you must always choose an answer, you can just choose A. Okay. Yep. Question 22. So 22. So what's the derivative here? So for this derivative, you bring down the power, differentiate the core, multiply by the core, and subtract 1 from this power. So this is going to give us 12 into 3x plus 2, or that's the power 3. So our key here is C. Okay, question 23. The equation of the circle that passes through the points, or that passes through the origin and the points 2, 0, and 0, negative 4. What's the equation of that circle? So since the circle passes through the points, the center, we know that using the general equation of a circle. So we have x squared plus y squared plus ax plus by plus c equals 0. So our c is equal to 0 because it's passing through the center. Now when you pass it through the point 2, 0, you're going to have 4 plus 0 plus 2x plus 2x plus 0 equals 0. So from here, x will be equal to, or let me say, sorry, a, that's 2a. A will be equal to -2 and when you do the same thing, when you pass it through the point 0, -4, you start about b is equal to 4. Okay, and find that the equation will be the first one. When you substitute the values, you have the first one. Question 24. The region bounded by the curve y equals 2x minus 1 over x and the lines x equals 1 and x equals 3 is. So that region, the area will just be equal to the integral from 1 to 3 of 2x minus 1 over x dx. So this is going to, when you integrate this, you are going to have 2x squared, 2x squared on 2, which is x squared, minus ln x from 1 to 3. So this is what this is going to give us. So it's going to give us a 9 minus, when x equals 3, we're going to have 9 minus ln 3 and when x equals 1 minus 1. That's going to give us 8 minus ln 3, right? So that's going to give us 8 minus ln 3, which is A. Question 25. A root of the equation x squared plus 2x plus 1 equals 0 is also a root of the equation x cubed minus 2x squared plus 6x plus k equals 0. The value of the constant k is. A lot of students had a problem with this question, but this is the trick. If you look at x squared plus 2x plus 1 equals 0, it has just one root and can be written as x plus 1 all squared equals 0. And solving this, x equals -1. That's the only root that it has. So since the common root, you're going to substitute in this equation here. -1 cubed is -1 minus 2 minus 6 plus k equals 0. So for me, it implies that k is equal to 9 when you solve for k. So the key is A. But if you want to go and equate the two, you will suffer so much to come out with this and you'll just be traumatized in the exam. So always look for short means, short methods that can always get you to things doing. Once again, you are watching this video from the GCE panel online, and you can go to our website www.gcpanel.org.org. I know I have other extensions like .com, .online, but .org to have this paper and maybe the corrections. Okay? And please don't forget to subscribe to this channel, to share and to your likes. Most of you watch these videos, you don't even make a like, a comment, a thumbs up, nothing. You're not even subscribed to the channel. But anyway, there's some of the videos I cannot watch if you're not subscribed. So those are some of the things you'll be missing out. But please, to promote this channel, to play your own part, make sure you subscribe to this channel. Make sure you share the videos to your other groups, in which study groups, Facebook, or whatever, on WhatsApp. That's going to help us know the type of content you like so that we create more. You can start for some time that we might not have been creating content because we are not seeing this. I promise you that if you get 100 likes or comments, we are going to come out as many videos as possible in this short time to play for this June 2025. If you share these videos, get a lot of likes, comments, subscribers, we will do the magic for you. So please, we are counting on you. Thank you so much in advance. Question 26. A periodic function f of period 4 is defined by f of x equals that. Find f of 9. So our period is 4 and our x values range from 0 to what? To 4, right? Now this f of 9, this 9 is outside this range from 0 to 9. So since it's outside, we can subtract multiples of the period 4 from 9 until we get a region that is a value that is found in this range, okay? So from here, we know that f of 9, if you subtract 4 from it, it's also the same as f of what? F of 5. but 5 is still outside this region because from 0 to 4. You see, subtract 4 again, we're going to have f of 5 minus 4 is 1, right? F of 1. Now, do we have 1 here? Yes. So this 1 that we have, are we going to use the first part of this function or the second one? Of course, use the first part because 1 is found within this range. The range where 1 is found is this first one. So this is going to give us 1 squared, which is 1. You can see how cheap the thing is, right? Question 27. Two functions f and g are such that f of x equals 2x minus 1 and f of g of x equals x minus 2. What is g of x? So for these composite functions, this one is our equation 1. We know that f of g of x is equal to x minus 2. Now let's also find f of g of x. So now f of g of x here from this one will be equal to f of g of x will be equal to 2g of x minus 1. These are equation 2. Now since these two are the same, this f of g of x and this f of g of x means that these sides are also the same, right? So this implies that 2g of x minus 1 equals x minus 2. From here it implies that our g of x will be equal to x plus 1, minus 1 on 2, x minus 1 on 2. So that's the key, the B. Okay, so number 27 we have B. Question 28. Question 28. Question 28 is on tangents. The equation of the tangents to the curve y equals 3x into 2 minus x squared at the point 1, 3 is. So at the point 1, 3, we need the y dx or y prime. Y prime will be equal to, we differentiate this, what they're going to have. Normally this function here is 3x times 2 is 6x minus 3x to the power 3. So differentiating this will give us 6 minus 9x squared. Okay. Now, so y prime of 1, because at the point x equals 1, right? Y prime of 1 will be equal to 6 minus 9, which is negative 3. That's our gradient m. Now, the equation of the line is given by y equals mx minus x 0 plus y 0. So this is going to give us negative 3 into x minus 1 plus 3. And when we simplify all of this, we're going to have bring this to the x, we're going to have 3x plus y, 3x plus y, so minus 6 equals 0. 3x plus y minus 6 equals 0. So our key is B. Okay. Question 9. So let's go to question 9. Sin 5x minus sin x altered on sin 4x minus sin 2x gives. We want us to simplify. So for the numerator, we are going to have 2 cos 5x plus x is 6x divided by 2, 3x. And then sine 5x minus x is 4x, right? Divided by 2, 2x. All this on the denominator, we are going to have 2 cos 4x plus 2x, 6x divided by 2, 3x. And sine 4x minus 2x is 2x divided by 2, sine x. So this 2 cos 3x cancel out with this one. What sine 2x? Sine 2x is the same as 2 sine x cos x. All this on sine x. Sine x cancel out sine x, and you're left with 2 cos x. So this 2 cos x here. Okay. Question 30. The number of arrangements of the letters of the word arrears is. So how many A's do we have? We have 2 A's. How many R's? For the R's, we have up to 3 R's. We have 1, 2, 3. And the other letters are just single letters. How many letters are there altogether? 7 factorial. All this one, 2 factorial for the 2 A's, 3 factorial for the 3 R's, and the other ones are 1, so we don't really have time for them. So this is going to give us 7 times 6 times 5 times 4 times 3 factorial. Okay, all this on 2 factorial times 3 factorial. Just cancel out with this. 2 here 1, 2 here 2. So 2 times 5 is 10 times 6, 60 times 7, 420. That's 420. Question 31. In this expansion, the range of values of x for which the complete expansion is valid is. So the expansion to be valid, first of all, write it in this form. We have 3 plus x to the power a half, which is the same as. So you can bring out this 3 to make it to look standard, okay? So this is going to be the root 3, or divide all through by 3. 1 plus x on 3. So look at this very well. 3 into 1 plus x on 3, all this to the power a half, right? So we can bring out this root 3 now. So this now become what? Root 3 into 1 plus x on 3, all this to the power a half. Now this expansion is valid if the absolute value of this x on 3 is less than 1. So it's valid if the absolute value of x on 3 is less than 1. And when we solve this, we're going to have a key to be b. Okay? Because there we're going to have negative 1 is less than x on 3 less than 1. Multiply both sides by 3, we're going to have that answer. Okay? Question 32. So we have 1 plus 1 on 3rd plus 1 on 9 plus 1 on 27. So and then plus. So this is a sum of this is an infinite sum, right? Of what? Of a series. So this is just a series, right? An infinite sum of a sequence, or an infinite series. So here, since this is a GP, the common ratio is 1 on 3. The first term is equal to 1. So the sum to infinity will just be equal to 1 over 1 minus 1 on 3. And what that gives us? 3 on 2. So our key here is B. Question 33. The limit to infinity of 4x squared minus 1 on 2x squared plus 1 is. Since you are looking at the limit to infinity, and this is a rational function, we just consider the most important terms for the numerator of the denominator. For example, as x tends to infinity, 4 times infinity minus 1, that minus 1 won't affect anything, right? So this is approximately just the limit as x tends to infinity of what? 4x squared on 2x squared. Because x tends to infinity, subtracting 1 or adding 1 will not change anything. Now just cancel out this, and 2 here 1, 2 here 2. So this will just be the limit as x tends to infinity of 2. And what that value be? It's 2. Okay, so our key is C. Question 34. Question 34. The integral from 1 to 4 of x plus 3 on 3, on x, sorry, dx is equal to. So we can rewrite this as the integral from 1 to 4 of x divided by x is 1 plus 3 on x. Right, so we integrate, so we're going to have x plus 3 ln x, integral from 1 to 4. So this is going to give us 4 plus 3 ln x, ln 4, minus when x equals 4, so minus 4, minus 1, sorry, just minus 1, because ln 1 is going to be equal to 0. So we have 3 plus 3 ln 4, 3 plus 3 ln 4. Question 35, the last question before we move to the mechanics section. If you're not yet subscribed to this channel, you are not doing us any good and you're not doing yourself good, because some other videos that you'll be looking for, you'll not be able to see because you're not subscribed. And that's not going to be good news. And you're not encouraging us to make more videos. The reason why you're not seeing more videos is because you're not subscribed. You don't leave comments, you don't share, you don't do anything. So if you really want us to do more and you want to see the magic, let us get 100 likes, 100 comments, or even 500 subscribers in no time, and you see what you're going to do. Okay, so what's the determinant of this matrix? So using any of the methods, let's see. Using any of the methods, we're going to get the determinants. I'll copy this one again. -1, -1 to -1, 3. Okay, so let's go. So we have this. That's -4, -4, -9. Okay, then this other one here, we have 3, 6, -8. So 3 plus 6 is 9, minus 8, 1. And here we have -4 minus 4, that's -8. -8 minus 9 is -17. So what's 1 minus -17? I'm sorry, it's supposed to be this one. -17 minus 1 equals to -18. Or use any other method. So this brings us to section B, which is the mechanics section. Section B, which is the mechanics section. So question 36 reads: the position vector of a particle at any time t seconds is r, where r equals t squared plus 1i plus t cubed j. What is the velocity of this particle when t equals 2? So here, how do you get the velocity? By differentiating the position vector, right? So our velocity vector will be equal to 2ti plus 3t squared j. So when t equals 2, we're going to substitute here, right? 2t, so that's going to be 4i plus 2 times 2, 4 times 3, 12, 12j. 4i plus 12j meters per second. Okay, so we have the question 37. The extension of a row of extension force of 20 newtons produces in a spring a natural length of 5 meters, whose modulus of DC is 150 newtons. So what will be the extension? You know that F is equal to kx, right? And from here we have our force is 20. Okay, so our x will be equal to F over k. So we have 20 over, what's the modulus of elasticity? 150. So it therefore means that we have 2 on 15, right? Over 15 meters. Okay, question 38. The velocity of a particle A relative to B is that. Given that the velocity of A is this, what's the velocity of B? So since it's a relative velocity, you know that of A relative to B, A relative to B means A minus B, and this gives us 7I plus 5J, and we have given us the value of A. So from what, how do you get the value of B? So B will be equal to A minus this value. So our B will be equal to A minus 7I plus 5J. This will be equal to 8I plus 6J minus 7I minus 5J. So this is going to give us 8I minus 7I plus 6 minus 5 plus J. Okay, so we have C. Question 39 is on probability. Given that A and B are events with probability of A equals 1/4 and probability of A union B equals 1/3, what's the probability of A intersection B? A intersection B is equal to a half. What's the probability of A given B? So the probability of A given by B is given by probability of A intersection B on probability of what? Probability of B, right? So this will be equal to 1 on 12 on okay, so right now we need the probability of B actually. Yep. So to get the probability of B, now probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So from here, our probability of B will be equal to probability of A union B plus probability of A intersection B minus probability of A. So this is going to be 1 on 12 on all of this, right? A union B, what's A union B? 1 on 3 plus A intersection B, 1 on 12 minus probability of A minus 1/4. So from here, when we simplify this, what will be the result? So what will be our result when you simplify this? 1 on 3, right? Good. So this is going to be 1 on 3 because here we have 1 on 12, and so 1 on 3 is the same as 4 on 12 plus 6 on 12 minus 3 on 12. So 6 plus 4 is 10 minus 3. Okay, so actually simplifying all of this is going to give us 1/3 when you do the simplification. Hope I'm not leaving out something. Yeah, I don't think I'm leaving out anything. Alright, in case of anything, guys, you can always check and then you make contact, okay? Yep, so that's one, so one sees what is missing or anything that is to be adjusted. Okay, question 40. Question 40. A small sphere of mass 0.6 kg is moving on a horizontal table with speed 10 meters per second. When it collides with a fixed smooth wall perpendicular to the table surface, it rebounds with a speed of 15 on 2 meters per second. The coefficient of recession between the sphere and the wall is. So our E will just be given by the velocity after on V before. Okay, velocity after is 2. It's 15 on 2. Divided by velocity before, which is 10, right? So what did this give us? That's 15 on 20, which is 3/4. 15 on 20, which is 3/4. So some of these answers can just eliminate them, like this one, 5 on 3, this is funny, right? And 4 on 3, these two are funny. Yeah, because already greater than 1, so it's going to be funny. Because the velocity after, it will be difficult for the velocity after to be greater than the velocity before for the equation of restitution. Question 41. 3 particles of masses 5 kg, 3 kg, and m kg lie on the y-axis on the points 0, 4, 0, 2, and 0, 5, respectively. The center of mass of the system at the point 0, 4. Center of mass of the system is at the point 0, 4. What's the value of m? So what will be the value of m? So to get the value of m, you have the 3 masses. Let me see, you have 0, 4, and 0, 5. Let's see. Lie on the y-axis. Oh, hold on. Lie on the y-axis at the points 0, 4, 0, 2, and 0, 5. Respectively, the center of mass of the system is at the point 0, 4. The value of m is, so at these points we have, let me say, 5 on the masses. The first mass is 5, so we have 5 times 5 times 4 plus 3 times 2 plus m times 5. All this on 5 plus 3 plus m, and the center of mass is just going to be equal to 4. This is for the y. 5 plus times 4 is 20, plus 6, 26 plus 5m. All this on 5, that's 8, plus m is equal to 4. So here we'll have 26 plus 5m to be equal to 1632 plus 4m. So from here, m is going to be equal to 32 on minus 26, right? 32 minus 26, what does that give us? 6. Yep, so it should be 6. Question 42. A car wheel of radius half meter is moving at a speed of 10 on 3 meters per second. Its angular speed in rats per second is, so the angular speed W is given by V on R, which is going to be equal to 10 on 3 divided by a half. Or let me just say times 2 times 2. 20 on 3, right? Question 43. 43. A car accelerates uniformly from a uniform velocity of 10 to 60 in 6 seconds on a straight road. What's the distance covered? So for uniform acceleration, S is equal to UT plus half AT squared. Okay. So do you know the acceleration? Yep. So here we can use this, or you can use the formula. Let me see. We have say F is equal to half U plus V times time. So this is going to be 10 plus 67, 6 divided by 2, 35. 35 times 6. 35 times 6 is 210. So we can use this, but can we get the acceleration as well? Acceleration is 60 minus 10, that is 50 on 6. So we put it in this formula, right? And then we see what we have. We already have 210. Let's see using this formula what we obtain. So we're going to have 10 times all of that, 500 on 6. Okay, 10 times t, sorry. 10 times t, that's 60, plus a half times a, 50 on 6, times t squared, 36, 6 here 1, 6 here 6, 2 here 1, 2 here 3, 50 times 3, 150, plus 60, 210. Alright, so any of them we use, we are going to see arrive at 210, but I think this first one was shorter. Question 44. A box contains 10 green and 6 white marbles. 10 green marbles and 6 white marbles. A marble is chosen at random, its color noted, and it is not replaced. This process is repeated once. The probability that the marbles chosen are of the same color is so according to this process, there are actually 2 draws. Okay, because that is chosen and it is not replaced, and this process is repeated just once. So what's the probability that the marbles chosen are of the same color? So there are two marbles drawn, right? So of the same color means okay, so the first, since they are green, 10 green, the first is green, that's going to be 10 over 16, right? So probably the first one is green, or can even use a tree. 10 green, that's 10 on 16 times the second one, if it's green, then the second one is going to be 9 on 15, right? If the 2 are green. Now if the 2 are white, we're going to have 6 on 16 times 5 on 15. So this is going to be equal to 90 plus 30 on 16 times 15. So we have 120 on the... Okay, let me see. 5 here, 3. 5 into 100 is 20 times 24 here. 8 here 2 times. 8 here 3 times. 3 here 1. 3 here 1. So we have a half, huh? A half. Alright, let's check this with a tree diagram and see as well. So this is our box here. So the first is green or is white. So for green we have 10 on 16 for the first row. For white we have 6 on 16. Green again we'll have 9 on 15. In white you're going to have 6 on 15. Here green you're going to have, so no green has been run yet, 10 on 15. The second white you're going to have 5 on 15. Yeah, so green is going to be 10 times 9, 90. White is going to 6.5, 30 over 16 times 15. That's 160. 160 plus 80 is 240. So we have 120 on 240, which is equal to a half. Yeah, it's true. Yeah, so that's the same. Anyone you use, you get the same answer. Question 45. Please make sure you subscribe to this channel. We're coming to the end of the paper already. So question 45 reads, just a moment please. The engine of a car of mass 1200 kg works at a constant rate of 69 kilowatts up a road inclined at sine theta. Theta equals sine inverse of 1 on 6 to the horizontal. Given that the no gravitational resistance to the motion of the car is 300 newtons, taking G as 10, what's the maximum speed of the car? So you know that the maximum speed, the acceleration is 0, right? And for a car that is on an inclined plane, on an inclined plane, let's see what we have. So up this plane we have the pulling force, okay, and the resistance, (300 newtons), and the weight of the car is 1200. This theta, and of course you have this mg sine theta. So 1200 times g times sine theta, which is 1 on 6. Okay, so this force up the plane is given by, you know that power is equal to force times velocity, right? So this force is going to be given by the power on what? Or how do you get this F here? So we can replace F by what? P on V, right? So this is P on V. So from this point, this is P on V. We have 1200 times this. Okay, 6 here, 1. 6 into 12, 2 times. So this is going to give us 2000. So 2000 plus 300, 2300. So here 2300, there's no space now. So 2300 is equal to force on velocity. Okay. So our power here is 69 kilowatts, right? So they're going to give us 69,000 on V. So from here, what's going to be our V? Our V will be equal to 69,000 divided by 2300. 0, 0, 0, 0. 23 here, 1, 23 here. So that's going to give us 30 meters per second. That's 30 meters per second. Okay. Question 46. The work done by a force F is equal to that. The work done by a force F equals that newtons, which moves its point of application from the point A with position vector RA. Position vector RA to another point B with position vector that is. So what's the formula for work done by a force that moves a point of application? Okay, since this one is just going to be force times velocity, right? So our force here F is equal to 1 squared plus 2 squared. That's 5 plus 4, 9. Square root of 9 is equal to 3, right? Oh, hold on. 4 squared is 16. 16 plus 4, 20. Plus 1, 21. So I'm going to take root 21. But there's another way to also tackle this. Now the work done is equal to force F dot something, right? So we're going to have 1 work done is F cos that. So 1, negative 2, negative 4, the dot product of work done. And okay, for this one, what's the difference? What's RA minus RB? So 3I minus I is 4. Minus J minus 4J minus nothing is minus 4. And 0, 3 minus 1 is 4. Minus 4 minus nothing is 0. 0 minus negative, so this is going to give us 6. So finally we have 4 plus 8. 4 plus 8 minus 24. Negative 12. But since it's work done, you take the absolute value, and that's going to give us 12, right? Okay, 12 joules. Question 47. A particle decelerating to rest has its speed v meters per second at time t seconds given by that. The deceleration of the particle when v equals 10 is. So when v equals 10, we can solve this equation, right, to get the values of t. Okay, so we have 6t minus a half t squared equals 10. So we have t squared, taking it that way, minus 12t, taking that way, so minus 12t plus 10 equals 0. So what will be the values of t here? So we have t Okay, let me take this again and see what's left out. Let me start by differentiating to get the acceleration. That's going to be 6 minus t. 6 minus t. So now at v equals 10, how do you get the time? You need to get the time, right? So we have 10 equals 6t minus a half t squared. So we have 20 equals 12t minus t squared. From you have the equation t squared minus 12t plus 20 equals 0. So we have t minus 10, t minus 2, so from here t equals 10 and t equals 2. So let's take 2 and see. As you know, it will be 6 minus 2. What's 6 minus 2? 4. But this one is going to be acceleration, right? So we need deceleration. So deceleration will be equal to 6 minus 10 negative 4. So we're going to take negative 4 because it says decelerating. Okay, this acceleration is positive. With decelerating, the acceleration is going to be negative. Okay, question 48. A uniform ladder AB of length 2a rests on a limiting equilibrium with its top end against a rough vertical wall and its lower end on a rough horizontal floor. The forces acting on the ladder are as shown. The angle theta AB, which makes the floor, is given by. So for this diagram, what else have we been to? The length is 2a. It's resting in limiting equilibrium. It is top end against a rough vertical wall, and its lower end against a rough horizontal floor. The forces acting are as shown. So we are going to look for the angle theta. So first of all, we know that let me see, for this force, this is 9 newtons, and this 9 newtons is not going to help us. This is 32. It's also 32. Okay, so you just need to take moment, right? Moment about a particular point. So where can we take the moments, at B or at A? Any of them, I think it's to be okay, right? Limiting friction. So we have so it's better to take moment at A, okay? So taking moment at A here, we'll have the following forces. So moment at A, for the clockwise moment, we'll have this 9 times perpendicular distance, 9 into 2a. So this is theta and this is 2a, right? So let's get this side. So sine theta will be equal to this distance, let's call it y over 2a. So y will be equal to 2a sine theta. Therefore x will be equal to 2a cos theta. So of this force is going to 2a times y, the perpendicular distance from this point. 2a sine theta plus this other one, the perpendicular distance from this point is 8 into 2a cos theta plus the weight is a half now, 40 into a sine theta this is anti-clockwise moment. This two turn it clockwise, one is turning anti-clockwise. So from here you have 40 that. So here we have 9 times 2a. So 18a sine theta plus 16a cos theta equals 40a sine theta. Bringing like terms, 16a cos theta equals, so we have 40a minus 18a, 22a sine theta. So dividing both sides by cos theta, we're going to have 16 over 22 equals tan theta. So it's going to be equal to 8 on 11. So tan theta is going to be equal to 8 on 11. Oh, I think I left out something. Please, guys, as you follow the video, please can you just work this out and you put the answer in the comment section. Thank you so much. I think I've left out something here. I've left out something actually. Okay. Left out something. Yeah, but I don't have enough space to check it out. So please just check and leave your answer in the comment section. Thank you so much. Question 49. That's what we are normally supposed to do to take moments. A particle of mass 14 kg rests on a smooth horizontal table. Is connected by a light inextensible string passing over a smooth fixed pulley fixed at the edge of the table. So let's say this is a table here, and the particle of 14 kg is lying here. It's lying here. 14 kg. Connected by a light inextensible string passing over a smooth fixed pulley fixed at the edge of the table to a particle of mass 6 kg, which hangs freely. Given that the acceleration of the system is equal to 3 when it's released from rest, the forces exerted on the string on the pulley is. So what we get, the force exerted by the string on the pulley. Okay, so I think I quickly check this one out. Yep. I did this one in my previous videos too, so I think you can just check this one out too and give the answer in the comment section. So I'm expecting the results for 48 and 49 so that I know if actually guys are watching these videos too or not. And the last question, a smooth sphere A of mass 6 kg traveling at 4 meters per second collides directly with a smooth sphere B of mass 3 kg. Please can watch out for paper 2 and paper 3 also. We're going to do the corrections for all of that. B of mass 3 kg traveling at 2 meters per second in the opposite direction. Given that the speed of B after impact is 2, the kinetic energy of A after impact is. So thank you so much for watching. So for assignments, you have question 48, 49, 50. If you have all three, you have done the assignment. You have two, you have done your best. You have just one, you have tried. Okay, so thank you so much for watching, and please subscribe and watch paper 2. We're going to compare our answers to what you have, and we see what comes up. Thank you so much for being there, and God bless you for your preparation for your exams. Bye bye. Don't forget to subscribe and to share.